Okay, welcome to my explanation of finding the diameter and a whole bunch of other things. So it's the first of a series of videos. So here is my graph. It's undirected and I've set all of the edges to length 1 just like we said in class. And then what I'm going to do, I'm going to use Dijkstra's algorithm to work out what the diameter is. So all that I've got here, I've just imported Dijkstra's algorithm. So this is it here. And that comes straight from building it as we did during isolation and according to the YouTube video that I made. So that's just there. So that's Dijkstra's algorithm there. So I've got my start node here of 6. I've got my end node here of 3. And if I run that, it's got a distance here of 4. So if we start at 6, we're going to make our way to 3. It's 1, 2, 3, 4 to get over to 3. It could have been 1, 2, 3, 4, 5, but Dijkstra's algorithm finds the shortest path, so that's what we want. So we can get from any two nodes, and we've got our distance there of 4. So we can check that, we can change that. So I'm going to change this and set this to 5. I'm expecting a distance of 3, and that's what we've got there. I'm going to change this to 1, and I'm expecting a distance of 1. And I'm going to change this to 2, and I'm expecting a distance of 2. So if we go from 2 to 5, or sorry, from 5 to 2, 5, we've got 1, 2, and that gives us our distance there. So that's Dijkstra's algorithm working for 2 nodes. Now, that's great, but we want to we want to automate this. We want this part here to happen automatically so that we can find out what the actual diameter of the graph is. So what do you think we need to do there? Well, if someone heard in class, we've got to put it into a loop, or possibly a nested loop. So let's say, so here we've got Dijkstra's algorithm again. So we're setting all nodes to infinity, and there it goes through to there, which is exactly the same as what we've got on the left. But what I did is that I put it in a loop. So I set the distance here. And what I'm doing is I'm working my way down to here. So what I've done is that instead of just reporting one distance, I'm adding it to a distance list. So I've made a list of distances, and then once it finds that, it then resets all nodes to infinity, and then it runs through the algorithm again. So it runs through this one here. So that's what's going on here. So we've got a loop. So we've got a loop starting here. We've got a nested for loop. So we're looking at all the nodes, and like I said, it then adds it to a list. So if we run that, now I'm going to show you dist list. So that's a distance list, and here it is. Here it's saying it's 10. I think because I went through. I don't know why it's saying 10, but let's have a look. Okay, so we're going to run this. And there it is, 36, because there is 6 nodes, and every node has 6 connections. So what this does, this 0 represents a distance from 1 to 1. This represents a distance from 1 to 2, which is 1. This represents the distance from 1 to 3. So 1, 3 is 2. 1 to 4, 1 to 5, 1 to 6. Then it goes 2 to 1, 2 to 2, 2 to 3, 2 to 4, 2 to 5, 2 to 6. 3 to 1, 3 to 2, 3 to 3. So every 0 there is it linking to itself. So this last one here is 6 going to 6. This is 6 going to 5, 6 going to 4, 6 going to 3. So that's what we've got there. So that's our list that we've ended up with there. So then to find the maximum of that, I've made a variable here called graph diameter, and I'm just setting it to the maximum of the graph list. So I'll click on graph diameter so you can see it. We already know it's 4 because that's something we worked out before. But if I click on this, it'll actually work it out. So let's step through it to watch it slow down. No. So we can maybe set this to 0. So duplicate, set graph diameter within the graph diameter to 0. We click on that, we watch it, and it's set to full. Let's step through it so we can actually see it happen. And there it is, so it sets it out to 4. So what that does is this will search through this list, and whatever the maximum is, that is our diameter for our graph. So that's how you go about finding the diameter.